Good evening, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do another code review for you. I haven't done a code review in a few days because I've been busy studying. I've been studying really hard, and that's why I couldn't make a code review, because I was stuck on something and I had to figure out what the problem was before I could continue. So this code review I'm going to do is on a data set called Mini Dogs and Cats, and it's going to be a Numpy Logistic Regression neural network. And so I got some of the code, not all of the code, but some of the code from this GitHub account here from Grant Grasser. I've got some of the code from his GitHub account, but certainly not all of it, because I had a problem, and because I had a problem, I had to study and study and study and study and try to work around it until I fixed the problem. So we're using the Mini Dog and Cats Numpy Logistic Regression Neural Network, and this is saved in my Kaggle account in a Jupyter network. So the problem statement is classify dog and cat images. That's your problem statement. So after the problem statement, what we want to do is we want to import the libraries. So the libraries we're going to use is Numpy as NP, so that is to perform numerical computations. Pandas as PD. I don't think we had any. Yeah, we did have some pandas because we had to read the files. So, just in case we needed pandas, I made pandas. But what pandas does is pandas creates data frames, and it processes the data. Imported random for random number generation. Imported peel, so that's image. It manipulates your images. Imported CV2, that's computer vision. Again, that manipulates the images. Imported OS, which goes into the operating system. Import globe, and I think that was just in case I needed to delete a file. Import shuttail, again, that was like going into the operating system. Import matplotlib.pyplot SPLT, that's to visualize the data, and import Seaborn as SNS. And that said SND, but it should be SNS, but I didn't use Seaborn anyway, so it doesn't matter. So we're going to use OS to retrieve the files, and there's 20 files, 10 files of dogs and 10 files of cats. Now we're going to visualize the images, because I like to visualize images. So we're going to visualize the images of a dog, number 9, and visualize the image of a cat, number 9. And so we're going to print the size of the image, and then we're going to show the image. So here you go. Here's the image of a dog and an image of a cat. And I'll also say that I will leave the link to the Jupyter notebook in the description box down below, so if you want to look at the code. Okay, so we're going to make a new directory in the working directory. So from pathlib, import path, and then path Kaggle working dogs and cats .mkdir parents equals true exist OK equals true. So we're making a new directory, and I forgot to say from pathlib import path in the beginning, but hey ho, I'm not rerunning it again just in case it doesn't work again, because I had a really hard time getting it to work, and I had to try a lot of things. Okay, now what we're going to do is we're going to clear the contents of the working directory. Files equals glob.glob Kaggle working star.star for FN files os.remove files. So we're removing everything from the working directory. And now what we're going to do is we're going to merge filters. So your source folder is Kaggle input mini dogs and cats dataset, and your destination folder is Kaggle working dogs and cats. And then so we take the original file and move it over to the destination file. So now what we want to do is we say number of pics equals 0, dir file names in os.walk, Kaggle working. So it's going to be print os.for file name and file names, print os.path.join, dir name file name, numpics equals numpics plus 1. So Kaggle working dogs and cats, cat, and then dog. And so you've got 10 images of cats and 10 images of dogs. And it says one of the files says Kaggle working notebook IPYNB, and I think that's the actual notebook. So it says you've got 21 files, but the only file we're going to be using is JPG. And then what we want to do is we didn't use it. I had shuffle and it says not used, so I didn't use it. But these are all the files that are in Kaggle working dogs and cats. And so you can see that because I had a really hard time because there was a file called virtual and I couldn't get rid of the virtual. And so that's why I did what I did to try to get rid of the file called virtual. So since there's only 20 files in there, you can see the 20 files that are in there. So we're going to set up our variables. mdog equals image.open, Kaggle working dogs and cats, dog10 JPG. Same thing for cat, except it's cat10. So print img dog size, print img cat size, and then we're going to show pictures of a dog and a cat, and so you can see that. You can see a picture of a dog and a cat. And it says show images in working directory. Okay, so now what we're going to do is we're going to set data dar equals Kaggle working dogs and cats, numpics equals 128, mtrain equals 16, mtest equals 4, and then you say ytrain equals np.zeros 1 mtrain, ytest equals np.zeros 1 mtest, xtrain equals np.zeros, mtrain numpics 3, xtest equals np.zeros, mtest numpics 3, and then you print it. You print how many trains, how many tests, and the first shuffled file. So it tells you you've got 16 trains for test, and the first shuffled file that you get is dog7 JPG. So now what we're going to do is we're going to read and store training images. So that when it says show images in working directory, I probably should have removed that. But as I said, I've done a lot of work just to get this to work. I worked on it for several days, and obviously I'm just on my own working. I don't have anybody to help me. So if I have a question, I just have to ask Google, you know. And on a separate note, something that's not to do with data science, I looked something up on Google, and my friend said, well, I've told you about using Google, but Google's all I have. All I have is Google and ChatGPT, and if it's not in Google and not in ChatGPT, I don't have anybody to ask. So I have to use Google, regardless of what some people may prefer. So now we're going to do read and store training images. So indices equals np.random.choice, numpics size equals mtrain plus M test, replace equals false. Then test indices equals indices 0:4. Train indices equals indices 4 colon to the end. And so you've got numcats train is 0 and numdogs train is 0. So now we're going to get the training images and convert them to a NumPy array. For IND and train indices, pick equals os.list dir data IND, that's index. And then label equals int, pick 0 to 3 equals dog, ytrain 0, train index in IND equals label. If label equals 0, numcats equals numcats plus 1. Well, numcats train equals numcats train plus 1. If label equals 1, numdogs train equals numdogs train plus 1. So now we're going to read the image to a NumPy array. So img equals image.open data plus pick. img equals np.asArray img. So you're taking the image and you're converting it to a NumPy array. And then you print img shape. If img is none, print image is none. Because if it's none, it's not going to work. img resize equals cb2.resize img numpix interpolation equals cb2 enter area. Xtrain train IND equals img resize. Train IND equals train IND plus 1. And then shape, so you get your shape of your Xtrain, shape of your ytrain, and then you get number of numcats train and number of numdogs train. So you get all the shapes. You get the shapes of all the images. So we get the shapes of all the images. We get the shape of Xtrain, which is 16, 128, 128, 3. Shape of ytrain, which is 116. Number of cats and number of dogs is 8 each. We print ytrain, so that's your ytrain, so it's going to be 16. Now we're going to read and store the test images, and this code is almost identical to the code for the train, with the exception that you're dealing with the test set and not the train set. But other than that, it's pretty much the same. So you can see you got the shape of the 4 test images, the shape of X test, shape of Y test, and number of cats and number of dogs. So on the test set, the number of cats and number of dogs should be a total of 16. No, sorry. On the train set, the number of cats and number of dogs should be 16. And on the test set, the number of cats and number of dogs should be 4. So now we're going to view the resized image. Index equals 1. plt.imshow xtrain index, and it's over 255 because it's converting the image to a 128, and so since the image is converted to 128, you divide it by 255, which will make it between 0 and 1. So we've got the image of the dog, and we've got an image of the dog for the, hold on a second, for the train set, and we've got an image of the dog for the test set as well. Now we're going to reshape and flatten the data. Xtrain flat equals xtrain.reshape, xtrain.shape 0, -1, dot t, x test flat equals x test dot reshape, x test dot shape 0, negative 1 t. And then you're going to print the x train flat shape, x test flat shape, y train shape, and y test shape. So now what we're going to do is we're going to standardize the data. So that x train final equals x train flat over 255, and x test final equals x test flat over 255. And really, it's 255 because the shape is 128. If the shape was larger than 128, it would be different than 255. And you could, in theory, say x train dot max, and that would be the same as 255, but they're just using 255 because the shape is 128, so that's what's happening. But I didn't want to change the individual's code too much because apparently he got it to work, and I spent so much time just trying to get it to work. I didn't want to change the parts that did work. So now we're going to talk about logistic regression. So we're going to define the function of sigmoid function, def sigmoid z, s equals 1 over 1 plus np dot exp negative z, and then it says return s. And so now we're going to, this is just to test the sigmoid. So sigmoid with the 2 is 0.88, and a sigmoid with 0.5 and 1 is 0.62 and 0.73, and that's just to test the sigmoid. Okay, so now we're going to initialize w2 vector to 0 stem 1. So def init parameters dim, w equals np zeros, dim comma 1, b equals 0, and it says return wb. So now we're going to test the initialization function. Okay, and so now what we do is description, properties forward and backward in the network, calculating activations and gradients, input, weights, training set x, vectors of labels y, returns the loss j, and the gradients dw and db. So def propagate wbxy, m equals x dot shape 1, and then we calculate the activations and loss. Then we do back propagation. Then we do return the gradient and loss, and the function returns the gradient and the loss. And then so now what we do is we test it. We put some figures in there and we test it to see how it works. And now what we do is we have another function called optimize. So this is the optimize function. Performs gradient descent minimizing W and B. Inputs weights, biases, X data, and Y labels. Number of iterations, learning rate when updating, and whether to print the cost or not every certain amount of steps. Returns params, dictionary, W and B, grades, gradients of W and B, and costs used to view the learning curve. So here is your optimize function, and it returns params, grades, and costs. So it tests that as well. So now we've got the prediction, the def predicts, so that's what we're interested in, prediction. So the description predicts 1 dog or 0 cat using sigmoid. Input weights, bias, training set X, returns Y pred, a vector. Numpy array with all the predictions and thus size 1n. So here's your prediction. Def predict WBX, M equals X dot shape 1, ypred equals np.01m, w equals w.reshape x.shape 0, 1, and it says get the probability. A equals sigmoid np dot w dot t x plus b. For I in range A shape, if A 0 I is greater than 0.5, ypred 0 I equals 1, else ypred 0 I equals 0. And then it says you return the ypred. So basically, if it's greater than 0.5, it's a dog, otherwise it's a cat. And then so now what you do is you test it. They give you some test data and you test it as well. So now we set our model, we define our model. So def model, x train final, y train, x test final, y test, num iterations equals 2000, learning rate equals 0.5, print cost equals false. And then so this is your model. And WB equals init params, x train final shape 0, params grads cost equals optimize, W comma B comma x train final comma y train comma num iterations comma learning rate. W equals params W, B equals params B. And then it says you make your predictions. So ypred train equals predict WB x train final, ypred test equals predict WB x test final. So now it says you print your errors, and then so you print your train accuracy and you print your test accuracy, and then it gives you results and it returns your results. And then we check X train final shape, which is 49152 as 16 columns. So you results is your model because model is a function. So train accuracy is 100% and test accuracy is 50%. So that's it. That's it for this code review. And obviously, there were a few things that I could have done better, like I could have deleted something, but I'm not going to do it because it might not work again. I did get it to work. So I will leave the Jupyter notebook in the description box for you if you would like to look at it and fork it and do whatever you want with it. But I did my best, and because I did my best, that's why I wanted to show it to you. So thank you so much to my subscribers for supporting my channel. If you like this video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you again for watching my video. I look forward to making more videos for you in the future.